Good morning, dear children. Now we are discussing P block element 1. There is a topic 2. The last class we discussed that structure of carbon dioxide, preparation of carbon dioxide, properties of carbon dioxide. Next, what are the application, that means uses of carbon dioxide, silicon tetrachloride and also silicones. Today our learning objective is to learn about what are the types of silicones and uses of silicones, and what are silicates, what are the types of silicates. Okay, everyone, we have learned today that the types of silicate up to, I think that today we can be complete Arthrosilicate, Pyrosilicate and also one more silicate, a Cyclic Silicate. That much we can be discussed. Okay, please all of you take the book, we can be discussed one by one. The types of silicones can be classified into three types. One is about that linear silicones, cyclic silicones, and the next one cross-linked silicones. The three types, one is about that linear silicones, second one cyclic silicones, third one cross-linked silicones. Before that, we can be discuss what are silicones. Silicones, that is already previously discussed that one. I read previous day, that is yesterday we discussed that one. What are silicones? Silicones are an organosilicone polymer. What are silicones? It is one of the organosilicone polymers. What is the other name of silicones? Polysiloxane. Polysiloxane. Then preparations, structures, everything we learn, right? Next, what are the three types of silicones? One is about that linear silicones. What is the second one? Cyclic silicones. And the third one is cross-linked silicones. One of the three mark question. Am I right? Here, what is about the linear silicones? The linear silicones are obtained by the hydrolysis and condensation of dialkyl silicon chloride. Dialkyl silicon chlorides, otherwise diaryl silicon chlorides. That means here the linear silicones, we need the linear silicones. For that we have to take dialkyl silicon chloride, otherwise diaryl silicon chloride undergoes hydrolysis and also condensation, we get linear silicone. What is the meaning of hydrolysis? Hydrolysis. What is the meaning of hydrolysis? Hydrolysis means simply we are adding water. Am I right? Water. Adding some water. That process we are saying hydrolysis. What is about the condensation? Condensation is during the condensation, what happened? The change of water, that is a water vapor, from the gaseous form to liquid form. Am I right? The change of water from gaseous form into liquid form, that we are saying condensation. One of the gaseous form is converted into liquid form, that we are saying condensation. Dialkyl. Alkyl means we know that R is, we are saying alkyl. Am I right? R. That is alkyl means CH3, methyl, ethyl, CH3, CH2, ethyl. So alkyl group, YL group. Alkane is converted into alkyl. What is the formula of alkane? CnH2n plus 2. Am I right? Here example, what are the example here? Methane. What is the formula of methane? CH4. Am I right? What is about the ethane? CH3, CH3. Am I right? CH4. This is which group? Alkane group. Alkane. ALKANE. When I am replacing one hydrogen from methane, I am going to replace it. I'm taking one hydrogen from methane. So what is the formula? CH3. Now alkane is converted into alkyl. Yes or no? Alkane is converted into alkyl. Alkane, ALKANE, is converted into alkyl, ALKYL. That is, methane is converted into methyl. Am I right? Methane is converted into methyl. That we are saying alkyl. Okay, can you understand? Next about aryl. Aryl. Then what is about the aryl? We are saying, for example, benzene. We are taking benzene. This is the formula of benzene. Am I right? Structure of benzene. I am adding one chlorine. So we are saying aryl chloride. Am I right? Aryl chloride, chlorobenzene. So dialkyl, diaryl. That means two molecules. Di means two. Am I right? So commonly we are writing here dialkyl means what is that one? R2. Am I right? R2 means dialkyl silicon chloride. Am I right? Silicon chloride. That means we are saying here SiCl, maybe Cl2 or Cl3 like that. Am I right? These are some examples we can be discussed one by one. Okay, now linear silicone, how it is obtained? Linear silicone is obtained by the hydrolysis and also the condensation of dialkyl silicon chloride. That's about the linear silicone. Here we have two more examples here: silicone rubbers and also silicone resins. The silicone rubbers, so these are some silicones are bridged together, joining together by methylene group. Can you understand? What is about the silicone rubbers? The silicone rubbers, these are some rubbers are bridged. Bridged means joining. Okay, bridged together by methylene. What is about the formula of methylene we are saying? That is CH2. Am I right? CH2 we are saying methylene group. Second one, silicone resin. Resin. Okay, silicone resin. What is about the resin? One of the sticky substance that is produced by some breeze. Am I right? That is used for making varnish, medicine, etc. Here also we are getting silicone resin. This is this is obtained by blending silicones with organic resin. Blending silicone means that these are obtained by mixing. We are mixing the silicones. Am I right? Mixing the silicones with organic resins. Then acryl ester. What is about the acryl ester? Acryl ester means some of the ester is used for making for the polymerization. Used for thousands of polymers. Polymers means one of the small groups are linked and making a long chain like that. That we are saying some of the group, ester group, some of the ester group. Am I right? Ester means all of you know that one. COO group. Next about the cyclic silicones. What is about the cyclic silicones? The cyclic silicones are obtained by the hydrolysis of R2SiCl2. R2SiCl2. What is about the R2SiCl2? What is the name? R means alkyl, am I right? So R2 means dialkyl. How much chlorine is there? 2 chlorine. So you can be say dialkyl dichlorosilane. Dialkyl dichlorosilane. How can you write the example here? Dialkyl. Dialkyl means we are writing R2. First you have to write silicone in the center. Silicone. Above we are writing R. Below also we are writing R. So dialkyl. The both two ends we are writing ClCl. Am I right? Suppose I am going to hydrolysis this product. I am going to adding some water. I am taking 2 molecules of water. Water can be written as HOH. Am I right? This side also HOH. When it undergoes reaction, what happens? The hydrogen combines with the chlorine. Hydrogen combines with the chlorine. We get what? HCl. And also next side also hydrogen combines with the chlorine. What is the product? HCl. So this OH will be attached here. This OH also attached here. So what is the product? Can you say what is the product? HOSiOH. This also attached here. RR. This is one of the product. and again some more reaction like that undergoes polymerization. We get one of the big compound, am I right? That we are saying cyclic silicones. Okay, cyclic silicones we have to learn tomorrow. Okay, next about cross-linked silicones. Okay, cross-linked silicones. What is about the cross-linked silicones? These are the silicones are obtained by hydrolysis of RSiCl3 or SiCl3 or SiCl3. What is about the R? Alkyl. Am I right? Alkyl. Next, what is about the Cl? Chlorine. Am I right? How much chlorine is there? 3 chlorine. So, alkyl trichlorosilane. Alkyl trichlorosilane. Already we learned this one. Am I right? Already previous we learned that one. Dialkyl, dichlorosilane. Okay, these are some examples we learned here. Alkyl trichlorosilane. Okay, this is an example. This undergoes hydrolysis. What is happening here? R Si. Suppose I am writing here 1 Cl, above 1 Cl and below 1 Cl. Suppose I am adding 3 molecules of water. Can you say what is the product? HOH, HOH, HOH. So hydrogen combines to chlorine. What is the product? HCl. Here also hydrogen combines to chlorine. What is the product? HCl. Here also hydrogen combines to chlorine. What is the product? HCl. So what are the products is possible here? R, Si, one side OH, other one OH, other one OH. Am I right? So this we get one of the compound. This undergoes again polymerization. Here water molecule is leaving out. Suppose I am taking one more compound. Sometimes I am writing one more compound here. OH, Si, OH, OH, R. So what happens here? Hydrogen combines to OH. What is the product? Removal of water molecules. So which are the possibility here? R, Si, above OH, below OH. Here joining the oxygen molecule, oxygen atom, am I right? Oxygen, Si, OH, OH, R. This is one of the compound like that. You can get a different compound. Anyhow, these are about the types of silicones. Next, we can learn about the properties of silicones. The first point, the extent of cross-linking and the nature of alkyl group determined the nature of polymers. The extent of cross-linking and the nature of alkyl group determines its nature of polymers. This polymers ranges from oily liquids to rubber-like solid. All silicones are water repellent. We know that about the water repellent means water cannot be entered. Am I right? So we are seeing the water repellent. Why it is happen means this property is erased due to the presence of some organic side group. Okay, some of an organic group, side group that is surrounded by silicon molecule. Okay, here one more point is about that properties. The silicones are thermal and also electrical insulator. So what is the reason? That is why silicones are used as the insulating material in electric motors. This is used as an insulating material for electric motors. And also silicones are chemically inert. Chemically inert, that is inert means it is not reacting. Am I right? Next about that, here having lower silicones and also having higher silicones. What is about the lower silicones means they are oily liquids. What about the higher silicones? That means they have waxy solid. They are waxy solid. These are some properties. At least you have to learn about any 5 points. Okay. Next, a very, very important question. What are the uses of silicones? A very important question. Very important 3-mark question. Silicones are used for low temperature lubricant. What is the first point? Silicones are used for low temperature lubrication and in vacuum pump, higher temperature oil bath, etc. Silicones are used for low temperature lubrication. Second one, in vacuum pump. Third one, high temperature oil bath. Here we are using. Okay, already we learned about that silicones, am I right? Second one, it is used for making waterproofing cloth. Water, because it is a water repellent, am I right? Water repellent. So, water cannot be enter here. So, used for making waterproofing cloth. Third one, silicones are used as an insulating materials in electric motors and also other electric appliances. What's the reason? They are also a thermal and also electrical insulator. What is the reason? They are used as an insulating materials in electric motors and also other appliances. The fourth one is a very, very important point. The silicones are mixed with the paints and enamels to make them resistant towards high temperature, sunlight, dampness, and also chemicals. These are some uses. At least try to learn 3 points. Okay. Next, we can be discuss about that silicate. Silicate is one of the important question. Silicates. Here, what is about the silicates? That means one minerals that contain silicon and oxygen. Can you understand? One of the minerals that contain silicon. Silicons means all of you know silicon. What is a symbol of silicon? Yes, am I right? Silicon and oxygen in tetrahedral units. Tetrahedral means we know that one of the center of an atom is surrounded by 4 different other elements, am I right? Other atoms that we are saying tetrahedral. Okay, we can discuss the structure also. So anyhow, what is about the silicate? One of the minerals which contain silicons and oxygens in tetrahedral units linked together in different patterns are called as silicates. For example, one of the unit is about that SiO4 4 minus. SiO4 4 minus. This is one of the tetrahedral units. Okay, tetrahedral units. Here, in our earth crust, nearly 95% of the earth is composed of silicate minerals and also silica. Silicate means all of you know that one about the sand. I'm right. We are discussing about the sand. The glass and the ceramic industries also is based on the chemistry of silicates. Anyhow, we can be discuss about the types of silicate. It's a very important types of silicates. Very important question. The types of silicate means the first one is about that Arthrosilicate. Arthrosilicate. What is other name is about that Nesosilicate. Okay, Nesosilicate. Second one is about that Sorosilicate. Otherwise we can be say Pyrosilicate. Okay, Pyrosilicate. Next one is about that ring silicate. Ring silicate. And also we can be say other name is about the Cyclic Silicate. Next about the Silicate. This has have some category, some of the classification. One is about that chain silicate. Next about that double chain silicate. Next about that we can be say about that third one is a sheet silicate. Sheet. Otherwise we can be say pyrosilicate. Next one more is about that 3-dimensional silicate. Okay, 3-dimensional silicate. Otherwise we can be say tectosilicate. Tectosilicate. Okay. So what are the types of silicate here? Can you say what are the types? Here, first one Arthrosilicate. What is the other name of arthrosilicate? Nesosilicate. Second silicate is about that sorosilicate. What is the other name of sorosilicate? Means pyrosilicate. The third one is about that cyclic silicate. Otherwise we can be say ring silicate. Okay, ring silicate. Next one is about that inosilicate. Okay, fourth one is about the inosilicate. Inosilicate is, they are classified into chain silicate, double chain silicate, sheet, or we can be say pilosilicate, three-dimensional silicate, we can be say tectosilicate. Am I right? Three-dimensional silicate, otherwise called tectosilicate. Here, each one have the different structure. Okay, we have to learn that one. What is the other name of arthrosilicate? Means nesosilicate. Here artho, the first letter O refers to one. One means this type of a silicate containing only one SiO4 4 minus units. How much SiO4 4 minus units? Only one. Am I right? So this is the simplest silicate which contain discrete SiO4 4 minus tetrahedral units are called as arthrosilicate. O refers to it contains one unit having SiO4 4 minus tetrahedral units. What is about the SiO4 4 minus? The charge. How can you find out the charge? Already many times we discuss about that. How we can find the charge. Am I right? How we get 4 minus. Listen all of you. The atomic number of silicon is 14. The first shell we can accommodate 2 electrons. Second shell 8 electrons. Third shell we can accommodate 4 electrons. Am I right? So, outermost having 4 electrons. We know that one because the valency of silicon is 4. This belongs to carbon family. Am I right? Carbon family. Okay. Anyhow, oxygen already we know that one oxygen atom is minus 2. So if you are counting here means Si means plus 4 plus 1 oxygen is minus 2. How much oxygen is there? 4 oxygen. So 4 into minus 2 we can be taken as X is equal to X. So plus 4 minus 8 is equal to X if you are taking X. So what's the answer? We get minus 4. So what is the charge here? Minus 4. So SiO4 4 minus. Here arthrosilicate, that O refers to it containing only one SiO4 4 minus units. Next about the example. What is the examples of arthrosilicate? What is the example here means? Olivine, O-L-I-V-I-N-E, olivine. And here, olivine having some element, which are the element means, we can be say like that Fe, otherwise Mg. And also other one of the element is about the silicon and also oxygen atom. So the formula we can be written as Fe or Mg2 SiO4. Mg plus cation and Fe2 plus cations are octahedrally surrounded by oxygen, that is O2 minus ion. Okay. What is one more example here? Phenacite, Phenacite, phenacite. That is the formula is Be2SiO4. Be2SiO4. B means beryllium. Beryllium 2 plus cation is, that is one of the ion, is surrounded by, tetrahedral is surrounded by oxygen ions. We can draw the structure. How can we draw the structure? First we taken as a silicon as the center. The silicon atom is surrounded by 4 different oxygen atom. 4 different oxygen atom. Okay, so we are drawing here like that. We get a structure of arthrosilicate. Each oxygen carrying minus charge. That means each oxygen gain an electron. So this SiO4 4 minus unit containing 4 extra electrons. Am I right? 4 extra electrons. Okay. This is about the arthrosilicate. Next about that. Sorosilicate. S-O-R-O. Sorosilicate. Otherwise, we can be say pyrosilicate. P-Y-R-O. Pyrosilicate. Sorosilicate. Otherwise, pyrosilicate. Yes. What is yes refers? Second type silicate. Am I right? Second means 2. Am I right? Second type silicate. 2 means it contains 2 SiO4 4 minus unit. It containing this type of the silicate containing 2 SiO4 4 minus tetrahedral unit. Okay. What is about the arthrosilicate? O refers to 1. Don't forget that. O refers to 1. 1 means it containing SiO4 4 minus units. Here O refers to one more example. What is the example? Olivine. What's an example here? Olivine. Don't forget that. I will ask the question. Okay. Next about the sorosilicate. Otherwise we can be say pyrosilicate. Yes refers to second. Am I right? Second. Yes refers to second. Second means it containing 2 SiO4 4 minus units. Okay. Here, this is one of the silicate. Sorosilicate means it is one of the silicate. It contains Si2O7 6 minus ions are called as pyrosilicate. We can be say sorosilicate. How they are formed, how the sorosilicates are formed. How they are forming means they are formed by the joining of SiO4 4 minus tetrahedral units. 2 SiO4 4 minus tetrahedral units are joining. We get sorosilicate. Due to the joining, what happens, that you have to learn it. Due to the joining, what happens. Before that, while sharing means, how they are sharing means, one of an oxygen atom is at one corner. That means while I am drawing here the diagram, yes, silicon is surrounded by 4 oxygen atoms. 1, 2, 3, 4. This is another silicon. 1, 2, 3, join here. So, while joining these 2 units, the 2 tetrahedral units, one of the oxygen is removing. While joining, one of the oxygen is removing. So, what is the formula here? How the formula came? How much Si is there? 2 Si. So, we can written as Si 2. How much oxygen is there? 1, 2, 3, 4, 5, 6, 7. 7 oxygen is there. So the formula is Si2O7 6 minus. Am I right? So how the charge comes? Am I right? We can find the charge. How the charge comes here means 1 silicon means how much? +4. Am I right? It's a carbon family. It belongs to carbon family. The outermost shell having 4 electrons. So +4 +4. 2 into +4 is equal to, am I right? 8 + 8. We can say +8. How much oxygen is there? 7 oxygen. 1 oxygen having -2. So 7 into -2 is equal to -14. Am I right? So we are subtract here means +8 minus here I are writing -14. So what's the answer? -6. Am I right? So the charge is about that minus 6. Already we can be discussed like that. Next, we can be discussed about the cyclic silicate. Cyclic silicate. Otherwise, we can be say ring silicate. Ring silicate. Okay. Cyclic silicate. Otherwise, we can be say ring silicate. I'm sorry to say about that. Examples of pyrosilicate. Examples of pyrosilicate. I forget to say. What is about the example? Examples means thortvetite, thortvetite, thortvetite. Okay, here, what's the formula means? SC2, Si2O7. SC2, Si2O7. Scandium. Sc means scandium. Scandium. Here we are using scandium, silicon, and also 7 oxygen. So try to learn here. Sorrow means, who is the next one? Yes, after that, next letter is about T, am I right? So starting there, T. So the example is also like that, am I right? Thortvetite. Okay, T, start with T. Okay, so try to remember that one. Such a week when you remember, okay, after the yes, we have to have T, am I right? Thortvetite. Okay, next about the cyclic silicate. What is about the cyclic silicate? Here, cyclic silicate means make a circle like structure. We can be say like that. Okay. Cyclically, the tetrahedral units are linked. They are linking by tetrahedral units are linked by cyclically. Ring shape. That we are saying cyclic silicate. If you are looking the diagrams, that understand how about the cyclic silicate. Am I right? Cyclic silicate, it contains SiO3N and 2N minus ion. They are formed by the linking of 3 or more tetrahedral. 3 or more tetrahedral SiO4 4 minus unit cyclically are called as cyclic silicate. Here, one of the important point here means each silicate units share 2 of its oxygen atoms with other units. Each one silicate unit shares 2 of its oxygen atom with other unit. Okay, one of the examples we are taking beryl. Okay, beryl. B-E-R-Y-L, beryl. Listen, my dear children. Cyclic silicate, that is C, am I right? Before C, not after C, before C, that is A, B, C, like that. Before C, which letter is there? B, am I right? So start with there, beryl. B means what? Beryl. B-E-R-Y-L. Can you remember, my dear children? Can you remember? You such a way how to practice, then only we can be easily write the examples. Okay? Try to understand. Okay, here. If you are saying 2 or 3 times means very easy for you. Okay. For example, about that 1 means ortho 1. Am I right? Ortho 1. The example is olivine. Start with the O. Am I right? Don't forget that. Okay, one example is enough. Sorrow means second one. Am I right? Second means 2 unit. Okay. Then after the yes, which one is there? Thortvetite. Am I right? That also easily we can remember that one. Okay. Cyclic silicate. Example before C means beryl. Am I right? So such a we have to learn. Okay. Anyhow, here beryl means what is the formula? Be3Al2 SiO3 6 times. What's the formula? Be3Al2 SiO3 6 times. This is one of an aluminosilicate. Alumino because it is having aluminium. Am I right? That's aluminum is surrounded by 6 oxygen atoms. That's the reason. Octahedrally. Okay, octahedrally. First I am drawing the diagram. How can you draw the diagram about the cyclic silicate? You have to draw the diagram. Start with here one of the oxygen atom. Oxygen atom. Join here, we get one triangle, am I right? The center. Okay, center one silicate. Silica is there. And here we can be joined here. One triangle like that. Like the triangle, we get a triangle. Center silicate is also joining. Next here also joining here means we get one like that shape. This is one of the cyclic silicate. We get one cycle. I mean all the sides are closed. Am I right? There is no open chain. Am I right? The chain is about the closed. So we are saying cyclic. Next one more we have the one type of a big cyclic structure. So try to learn this one, the structure. First to write on benzene. Like that one of the hexane like that, okay, not benzene, cyclohexane. I'm drawing like that. This way we can be draw, am I right? Can you draw like that? We get cyclohexane, am I right? Cyclohexane is one of the shape like that, okay. That is a without ring of, no need to put the ring of benzene, okay. Only the ring only is having, now put the bond here, okay. Don't put the bond here. Okay, then here we can be joined like that, one of the triangle shape like that, one triangle, next two triangle, okay, three triangle, four triangle, five triangle, six triangle, am I right? So each corner having oxygen, 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 oxygen. The middle we can be right mention like that, silicon like that, okay, joining here. Here also you can be joined like that, join like that, join like that, join like that, join like that, okay. This is about the diagram. So my dear children, try to understand the concept and learn this question. Okay, today I am giving the portion about the assignment. Uses of silicone, the first question. Uses of silicones. Second one, arthrosilicate. The 3 line is enough. And the structure. And the example. Any one example is enough. Okay, any one example is enough. Arthrosilicate, that paragraph, example, and the 2 diagram is there. Cyclic silicate, the 4 line, 4 or 5 line they are having. Example, the example is enough. Don't write the remaining. Example is enough. And the 2 diagram, okay. Thank you all of you. Thank you. Have a nice day.